Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday night math night. I'm so glad to be back with you. We took a little week off last week for the Thanksgiving holiday. I hope that you guys all had an amazing week off or time off. So with that said, we are not going to waste any more time. For those of you who are new, welcome to Wednesday night math night. We're here every Wednesday, and I just go over about 8 to 10 problems with like he said, with a variation of ability. So we go pre-K through 12 on Wednesday nights. So unfortunately, about 5 minutes before we started streaming, my iPad decided to just go kaput, which means I cannot share my screen. So we're going to do it old school style. I'm going to share the problems with you on the screen, but then I'm going to work them out on paper because I cannot scribe on the screen on my computer, and my iPad just is not working. I have no idea what happened. It just shuts down on its own and it doesn't turn back on. So we will address that later, but you know, the good old joys of technology. So let's go ahead and get started with our first problem. And like I said, I'm going to kind of do it. Normally I make the problem a lot bigger and me a lot smaller, but we're going to kind of go back and forth so you can see how I'm solving these problems. So let's go ahead and get started with our first problem. So problems that I do not get to each week, I will always make sure that I include them the following week in our stream. So right now, this is a problem that we did not finish. If you see a problem A, B, or C, it's probably from the week before, and then we'll get started with the problems from this week. I will also drop a link later tonight in the chat box so that you can access all of these problems on your own. So like I said, I will drop a link in the chat box a little bit later tonight, and you will be able to access a blank copy of all of these problems. So problem A, describe the transformation that occurred from the equation f of x equals x minus 5 cubed to the graph of the equation f of x equals 1/2 x minus 3 cubed plus 2. A, shifted 5 units to the right. B, shifted 3 units to the left, shifted 2 units up, and a vertical stretch of a factor of 1/2. C, shifted 2 units to the right, shifted 2 units up, and a vertical stretch of a factor of 1/2. D, shifted 2 units to the left, shifted 2 units up, and a vertical shift of 1/2. So let's go ahead and look at the original problem. So the original problem that we have is f of x equals x minus 5 to the 3rd power. So what do we know about this problem? We know it's a cubic function, which is obvious because it's to the 3rd power. And what does that look like? Well, that looks like a graph that looks something like this is our cubic function. And that would be f of x equals x cubed with no transformations. However, we know that this has some sort of transformation because we have a minus 5 here. Now, this is definitely going to be a problem for our middle school, high school people for sure. Definitely 6 through 12. My 5 through 9, maybe not. However, my GK and 5 through 9, you definitely need to know how graphs transform and how they operate. So really, everybody should understand this kind of stuff. And like I said, as I go through problems, I'm going to definitely make sure that I'm trying to cover as many of you as possible. So we've got f of x equals x minus 5 to the 3rd power is the original equation. Well, what do I know about transformations? What do I know about this piece of information right here? I know that means I'm moving to the right 5. Now, don't get confused. A lot of people assume that negative means to the left because when I graph a graph, positive is to the right and negative is to the left. So a lot of people will assume that this is a negative or a left transformation. However, the original transformation rules say x minus h squared or cubed or whatever plus k. That's your original formula where h is your right and left and k is your up and down. And so if I've got x minus h in my original, then if it's minus up here, then that means it's going to be a positive. It's kind of confusing. Just know if you see a minus in your transformation, it really means you're going to the right. So that means I'm going to change colors here. I brought 2 different colors of pens because my iPad's not working. 1, 2, 3, 4, 5. That means that my original function for this problem is this red function. I just shifted it 5 units to the right. Now I'm looking at what am I doing to that problem to get f of x equals 1/2 x minus 3 cubed plus 2. Here's where some people are going to make their mistake. They're going to automatically choose B because if I write my new problem, f of x equals 1/2 x minus 3 cubed plus 2. So this is my new equation. And if we look at the new equation from the parent function, where parent function means you're like OG, like your original, which would be x cubed with no transformations. If I look at this from that, it would be 3 units to the right and 2 units up with a vertical stretch or shrink of 1/2. Well, that's not the correct answer because I'm not transforming f of x equals x cubed. I'm transforming f of x equals x minus 5 cubed. Big difference there. So it's important that you recognize what you're transforming. If I was transforming the parent function, then B would be the correct answer. But I'm not. I'm transforming this function into this function right here. So what am I doing to this black line to get this line? Well, let's go ahead and graph this line and then talk about it. So I'm going to take my black line and I'm actually going to graph it in green so that we have 3 different colors going on. Here's my green pen. So I'm going to go to the right 3 and I'm going to go up 2. So my new function, and I'm sorry that you can't see all of this. My iPad is just completely dead. Don't know what's wrong with it. It's fully charged. I don't know what's happening. So my new function is this green line right here. Well, how did that change from my red line, which was my original function here? Well, if I went from -5 to -3, which direction did I move that function? I went 2 units to the left and then 2 units up for sure. I shifted my original graph, which was the red line, 2 units to the left because I went from 5 over to 3 over. And then I went 2 units up. So my answer is actually going to be D on this problem. And again, I apologize for the inability to use this brick. It's not working. I don't know what's wrong with it. So we're just modifying tonight because we all want a little bit of math, right? So that's the answer to problem A. Let's go ahead and move into problem B. While I'm scrolling into problem B, go ahead and let me know where you're from. Where are you from and what test are you prepping for? I love to get to know my Wednesday night math people. So I like to get to know who's in the room. So where are you from and what test are you prepping for? I'm from Central Florida. My husband and I and our puppy, he's not really a puppy anymore, live in Seminole County, and we have a little one on the way that will be here in February. So we're super excited about that. All right, let me know where you're from in the comment box and what test you're prepping for. And we will continue on with problem B. A first grade teacher is teaching a unit on time. Which of the following skills is most appropriate for first grade students? A, telling time to the nearest minute. B, telling time to the nearest 5 minutes. C, telling time to the nearest hour. D, determining the time elapsed between 2 events. All right. Hey, Crystal from Texas and Erica from Northwest Florida. Francis, hello. Rabia, hello. Vicky, hello from Miami. Lots of Florida people and Texas people. I love it. Welcome, welcome. All right. This problem is really straightforward, and it's going to be particularly for our K through 6 test takers or pre-K through 3, because this is specifically a first grade teacher. So my K through 6 people, EC6, anything like that, and my pre-K through 3, this problem is for you. And if you don't know your math standards, well, you need to know a little bit about your math standards so that you can appropriately answer this question. Hey, Hope, welcome back. So in the state of Florida, the math standards state, and I believe it's the same for Common Core as well, that in kindergarten, students do not do time at all. They don't have to tell time. First grade needs to be able to tell time to the nearest hour and half hour. Second grade needs to be able to tell time to the nearest 5 minutes. And third grade needs to be able to determine the elapsed time between 2 events. I'll say that again because I can't write on my screen right now. First, kindergarten does not tell time. First grade tells time to the nearest hour and half hour. Second grade tells time to the nearest 5 minutes. And third grade tells time to the third grade does elapsed time. So I woke up at 6:30 and I have to be on the bus at 8:05. How much time do I have to get ready? That's a third grade standard. So for this problem specifically, the most appropriate skill for a first grade student would be to be able to tell the time to the nearest hour, C. If you know your math standards, that's going to be no problem at all. I have seen these kinds of problems with time and money a lot. I have seen these kinds of problems with time and money. So my elementary math people know those time and money and geometry standards, but even beyond that, just know what kind of scope happens K through 5. Like, know where those standards happen and where they're going. And you'll be able to answer this kind of question in no time at all. These kinds of questions are those time saver questions. These are those questions that allow you to save a little time. You read it, you answer it, you move on, and it gives you a little extra time on those problems that take a little bit longer to solve. So this problem is C, telling time to the nearest hour. This is a very similar problem. A second grade teacher is teaching a unit on time. Which of the following skills is appropriate? We just talked about this, so we're not going to spend a whole lot of time on this. This one is going to be telling time to the nearest 5 minutes because kindergarten doesn't tell time. First grade does time to the nearest hour and half hour, and second grade does time to the nearest 5 minutes. So this would be letter B, and we can just move right along. For those of you who are just joining us, welcome. Make sure you drop in the comment where you're from and what exam are you specifically prepping for. That's going to help me really understand where our room is and what tests we're prepping for, so that as I go through, even though they're set questions, I can definitely stretch them up or stretch them down depending on what tests we're prepping for in this room. All right. Problem number 1. This is the first problem that we didn't have leak over from another week. Which of the following properties was used to simplify the following expression in step 3 specifically? So if we look at step 1, that's the original problem. 5 times x plus 7 minus 3 times x minus 3y. So I'm going to go ahead and write that, and then I'm going to explain what I'm going to do here in a minute. So 5 times x plus 7 minus 3 times x plus 3y. So here's my original problem. What do I do when I see these kinds of problems specifically? When I see these kinds of problems, I get personally very confused when I look at someone else's work. So I will solve the problem or simplify the problem myself and then kind of compare my work. That's just how I do it. You may do it a different way, and that's totally fine. So 5 times x plus 7 minus 3 times x plus 3y. This is going to be a problem you're likely going to see GK, Praxis Core, but really everybody in this room needs to understand properties because they are on the elementary math. And then they're also obviously on middle and high school math. So what am I going to do first to simplify this? Because I can't solve it. There's no equal sign, but I can simplify it. I'm going to distribute. So I'm going to take this 5 and I'm going to distribute it through all the way through my parentheses. What does distribution mean? Distribution means literally that. I'm going to distribute or share it among my other players in my parentheses only. So I'm going to go ahead and do 5 times x and 5 times 7. And I'm going to do the same thing with this negative 3. Please remember that that's a negative 3. The negative goes with the 3. So I'm going to multiply that negative 3 times x and then negative 3 times 3y. Okay, so I'm going to use my distributive property in step 1. So 5x plus 35 minus 3x minus 9y. And when I look at my step 2, all they did was they took step 1 and then they said this is the same thing as this. That's what that equal sign means. They just rewrote this and then they said, hey, guess what? This is the same thing as this. Then what are we going to do after that? Well, here's where it gets tricky. I would go ahead and look for my like terms and combine them. But if we look at their step 3, they moved some pieces around to get the things that are alike next to each other. So I'm going to go ahead and do that too. So I know that my x's are going to need to be combined. So I'm going to take my 5x and my negative 3x, and I'm going to put them near each other to combine them. So I'm going to do 5x minus 3x minus 9y plus 35. All I did was pick up my puzzle pieces and move them around. That's all that happened from here to here. Then what am I going to do? Well, then I'm going to just simplify that. What's 5x minus 3x? 2x. That's definitely not an x. I tried to do that upside. I tried to get fancy on y'all and do it upside down, and it didn't work. And then minus 9y plus 35. Can I do anything else with that? Can I do anything else with 2x minus 9y plus 35? No, I can't, because x's and y's cannot be combined, and neither can constants. I can only combine my like terms. That's another thing that really trips people up. A lot of times I'll see people do 2x minus 9y and they'll get negative 7xy. Not possible. If it's not x's together and not y's together, there's nothing you can do about it. You got to just leave it. So if it asked us to simplify, that would be our final answer. But they asked us what happened in step 3. What did they do in step 3? What property did they use? Well, we used distributive property in step 1. And then there was no more distributive property after that. There was no more parentheses for us to distribute. Closure property, definitely didn't use the closure property. Commutative property, what is the commutative property? The commutative property states that I can move my addends around and it be the same problem. And that's exactly what I did. I moved my puzzle pieces around and I got the same thing. All I did was take this and move things around and I got this. And that's what the commutative property is in like layman's terms and not math terms. And then the identity property just states that like 5 plus 0 is 5. The identity property, or 5 times 1 is 5. Those are both identity properties, and that's not what we used here. So we used the commutative property in step 3, and we used the distributive property in step 1. So the answer to this specific problem would be commutative property, C. As I'm solving these problems, especially since I'm doing it old school on paper, if you have any questions at all, please do not hesitate to ask. I'm more than happy to answer any questions. So please, please, please drop in the comment box if you have any questions as I'm solving these problems. I want to make sure that we're all clear and that we all have a good understanding of what we're doing tonight, since the iPad is not working and I can't scribe on the screen. All right, let's move on to the next problem. Which of the following is equivalent to the number 341? All right, this is a really good one. So 341, I'm going to write that on my paper. Which of the following is equivalent? 3 plus 4 plus 1, 34 tens and 1 1, 4 hundreds minus 41, or 300 plus 4 plus 1. All right. Place value and showing numbers in different ways can be very tricky, not only for our students, but for us as well. So you have to understand how to decompose numbers and show numbers in a variety of ways. Now, this problem was modified from some problems and competencies from a K through 6 EC6 example. However, this is a great foundational understanding for everybody. So 341, what do I know about 341? I know that we have 1 1, 4 tens, and 3 hundreds. I know that I have 1 1, 4 10s, and 3 hundreds based on the understanding of place value. Let's go ahead and talk about place value really quickly because everybody needs to know about place value. So if I have all of these blanks for place value, I know that this is my 1s, 10s, hundreds, thousands, 10,000s, 100,000s. And then if I had a decimal place, which this number doesn't, but it's important that we understand it. If I had a decimal place, this would be tenths, hundredths, thousandths. So we have 1s, 10s, 100,000s, 10,000s, 100,000s, tenths, hundredths, thousandths. So in this case, our number is only going to fill those 3 place value spots, 1s, 10s, hundreds. I could draw this number. Second grade teachers are really used to this because they deal with 3-digit numbers. So I could draw 10, 100, 200, 300, 10, 20, 30, 40, 41. I could draw the number 341 using base 10 blocks. So I have 100, 200, 300, 310, 20, 30, 40, 341. So I know I have 300s, 4 10s, and 1 1. However, that's not an option. They don't have 300s, 4 10s, and 1 1. So now I have to go back to the drawing board. Is 3 plus 4 plus 1 341? No. 3 plus 4 plus 1 is 8. 3, 1, 2, 3, 4, 1. However, when you're mentally exhausted taking a math test like this, unfortunately, we all make silly errors like that because we see the number 341, we see 341, and we go, boom, answer. And that's not the case. 3 plus 4 plus 1 is 8. We all know that, but sometimes we make silly mistakes. So let's not make that kind of silly mistake. So if I had A, B, C, and D, A is automatically out. What else is automatically out? D is automatically out because 300 plus 4 plus 1 is 305 because 4 plus 1 is 5. If I were to do expanded form of this number, expanded form just means I'm taking this number and stretching it out. It would be 300 plus 40 plus 1. We're taking the value of the place that that number is in and stretching it out. So this is 3 hundreds. This is 4 10s, which is worth 10, 20, 30, 40. And this is 1, 1, which is just 1. So that means that D is out as well because 300 plus 40 plus 1 is not 300 plus 4 plus 1. All right. So now we're left with B and C. 34 10s and 1, 1 or 400 minus 41. Let's think about this conceptually. If I look at the number 341, I know I have hundreds, tens, and ones. However, what would happen if I broke these into tens? How many tens is 100? Well, let's count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's 10 tens and a 100. So if I broke these hundreds into tens, I would have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60, 70, 80, 100. 10, 20, 30, 40, 50, 60, 70, 80, 100. I would have 10, 20, 30 tens here. 31, 32, 33, 34 tens. And 1, 1. So I can decompose that number, which becomes really critical when we start to do addition and subtraction with regrouping. I can break that number down into 34 tens and 1, 1, which is letter B, which is our answer for this problem. All right, let's keep going. Again, if you have any questions, please don't hesitate to ask while I'm solving these problems, since I'm not able to showcase them as closely as I would like to tonight. Also, as we're solving problems, if you see something that you're like, man, I really wish she would have gone over some more geometry, or I really wish she would have hit on some slope a little bit more, or whatever you know you need help with, please comment in the comment box. It helps me develop the problems that we're going to use each week. So if you have specific content that you want me to cover over the next couple of weeks before the holidays, please let me know in the comment box so that I can make sure that I hit those for you in the next couple of weeks. All right, let's go ahead and read problem 3 together. A pool technician is filling up a pool and is monitoring how many gallons of water are in a swimming pool over a period of time. The technician recorded the gallons in the pool on each hour as shown below. Which of the following equations relates the hours passed, H, and the number of gallons in the pool, G? Which of the following equations relates the hours passed, H, and the number of gallons in the pool, G? 500G plus 100 equals H. 550H equals G. 500H plus 100 equals G. Or 2H plus 1100 equals G. Okay, for this kind of problem, I would highly suggest you just use your table of values, plug it into your answer choices, and move right along. Now, for those of you who are algebraically minded, who really love linear equations and slope and all of that, could I look at this table of values and think, okay, H is my X value, G is my Y value, what is my Y-intercept, what is my slope? Absolutely, you could do that. But is that going to be the quickest way to solve this problem? Probably not, because they didn't give us our Y-intercept. They didn't give us our hours past 0. And so, unfortunately, you're going to have to find all of that information. So I am going to sit here and I'm going to plug in all of my values. So A was 500G, and I will show my paper here in a minute, plus 100 equals H. And I always like to pick not the first and not the last value in the table of values. I don't know why. I just feel like sometimes the first one always works for a reason, because they want you to just pick that answer and move on. So I'll usually pick like the third or the fourth one. So let's decide that we're going to do 4 hours, which is equivalent to 2,200 gallons. So here's what I've written down, not gallons, gallons. Here's what I've written down so far. I've written down my letter A, and I've written down that I'm going to use 4 hours, or 4H, and 2,200 gallons. So I'm going to literally plug the 4 into H, and I'm going to plug the 2,200 into G, and I'm going to solve this problem right here. And I'm going to do that for every single letter. So if I plug in 500 times 2,200 plus 100 equals H equals 4. I don't even have to finish solving that. Why? Because I am very confident that 500 times 2,200 plus another 100 is going to be way more than 4. So I already know that letter A is out. And so now I'm going to move on to letter B. Letter B is 550H equals G. So I'm going to, again, take those values that I chose from my table of values over here, 4 hours, 2,200 gallons, and I'm going to plug them into here. So I'm going to plug my 4 into my H, and I'm going to plug my 2,200 into my G. So 550 times 4 equals 2,200. And I'm going to solve that and see if that's true. So if I have access to a calculator, I can just use my calculator. Some people have access, some people don't. My elementary people definitely don't have access to a calculator. So 550, for the interest of time and space, I'm just going to go ahead and type it into my calculator. 2,200 equals 2,200. Would you look at that? I don't even have to keep going. That is the correct answer. So B is the correct answer. Now, if you're like me and you like to extra make sure, you can pick another point. So I could pick 3 hours and 1,650 gallons and plug that into this same equation just to make sure it wasn't a fluke. Because guess what? Sometimes this is a linear equation, and sometimes we have linear equations that intersect, right? We have linear equations that intersect, and they could share one of the same points, but they're not going to share multiple. So if I test 2 points out, once I find one that works, then it's going to guarantee whether that answer is true or not true. So let's go ahead and test one more point just in case. 550 times 3 equals 1,650. I'm going to test this one in my calculator. 550 times 3. And of course I got 1,650 equals 1,650. And so I know, because I tested 2 points for this equation, that B is going to be my correct answer. Again, for those of you middle school and high school people who might be more linear equation minded, it might be, you might have desired to find the slope of this line, because really all of those equations are in y equals mx plus b form anyways. And so if you need to know slope and y-intercept, let's just go ahead and go there for a minute. I know that y equals mx plus b is the equation of a line. Elementary people, you do not need to know this. Y equals mx plus b is the equation of a line where m is your slope and b is your y-intercept. So if I'm going to look at these equations and figure out what this looks like, they did not give me my y-intercept. So I'm going to have to go backwards to find my y-intercept. What do I know about a y-intercept? I know that it's where my graph crosses the y-axis, which, what do I know about all y-intercepts? What do all y-intercepts have in common? They all have 0 for their x value, because I'm not going right or left any. So if I'm looking at a coordinate graph, and everybody needs to be able to understand coordinate graphs and how to graph, if I'm looking at my x, y coordinate pairs, all of these are going to have 0, y on my y-axis. So my hours, which I know where my x is, would have to be 0. So I would have to go from 6, 5, 4, 3, 2, 1, 0 to find that y-intercept. And then if I'm going to find my slope, we know that slope equals rise over run, which rise is just your y's, run is just your x's. And so I know that if I have points, because in this case I can't count rise this many, run this many, I can just, if I don't have a graph and I only have a table of values, I can do y minus y over x minus x. So I can take gallons minus gallons over hours minus hours to find that slope value, which is going to be 550. So that's the way you would solve this if you were being asked to do some sort of slope, y-intercept, or if that's just what you're more comfortable with. All right, that was like a massive rabbit trail. So let's go ahead and move on to our next problem. All right, it's the same problem, but I did this on purpose because I want you to know that there's a lot of different questions that your test creators can ask you about the same piece of data. So let's go ahead and look at this problem with a different question. A pool technician is filling up a pool and is monitoring how many gallons of water are in a swimming pool over a period of time. The technician recorded the gallons in the pool on each hour as shown below. Same exact table as before. If the pool the technician is filling up is 18,000 gallons, after how many hours will the pool be completely full? Okay, Two different ways to solve this problem. Use our answer choices to help us, or use algebra to help us. Same thing. We can do two different ways. So let's go ahead, and the first way I'm going to solve this problem is I'm just going to use my answer choices. Now, what I notice about this chart is I've got hours and I've got number of gallons. So if I figure out how many gallons per hour are being added to that pool, I can just keep adding those until I get to 18,000, right? Especially if I have a calculator, I can just keep hitting the equal button. If I don't have a calculator, I'm just going to do it by hand. So after 2 hours, I notice that it's 1,100. And after 3 hours, I notice that it's 1,650. And after 4 hours, I notice that it's 2,200. What is that difference between each hour? Well, I'm going to subtract 1,650 minus 1,100. Why am I going to subtract that? What is this going to tell me? This is going to tell me how many gallons went into the pool between the 2 hour mark and the 3 hour mark. It's going to tell me how many gallons are going into that pool per hour. So when I subtract those, I get 550. Beep, beep, beep. That's your slope for my slope inclined friends. That's 550 because then I would just be dividing it by 1, rise over run. So 550 gallons per hour. Are we following? 550 gallons per hour. Well, that makes sense because if my pool at 0 hours starts with no water, and then after 1 hour, it has 550, and then after 2 hours, it has 1,100, what can I do with that number? I can divide 18,000 by 550 to figure this out. So I could do 18,000 divided by 550 because this is the number of gallons per hour. So if I divide this number right here is going to be the number of hours it took to fill up the pool. So 18,000 divided by 550 gives me 32.7272. However, I want you to think about this. When will the pool be completely full? After 32 hours or 33 hours? It'll be completely full after 33 hours. Not because this rounds up. Even if, and I need you to pay attention to this because this is where they trick us. Even if this number, it's not, but even if it was 32.1, 32.1 technically rounds down. However, is the pool going to be completely full after 32 hours if it takes 32.1 hours to fill it up? No, it's still going to have a little bit of water left that it needs to fill up. So after 32.1 hours, it's still, or after 32 hours, it still won't be completely full. So I would still choose the 33, even though it didn't round up. But in this case, it would round up anyways, so 33 would be our answer. Now, if that process was a little bit more difficult for you, but you figured out that it was 550 each time, you could sit here and do 3,300 plus 550, and that would give me 7 hours. And then I could just sit here and go 8 hours, 9 hours, 10 hours, 11 hours, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, and that's going to put us over that 18,000 gallons. So it's still going to be 33 hours. That might be easier for some of you, and that's totally okay. Now, some of you don't even have a calculator, so you might have sat there and added all of those up by hand. That would take a while, but it still would give you the right answer. There are lots of ways to do it. Now, for those of you who came up with an equation for this, you would be able to just solve the equation for that number of hours by plugging in the 18,000 for your gallons. So I love these kinds of problems because it gives us a lot of different routes that we can solve it, but we can all get the same answer. All right, moving on to problem 4. Simplify the following problem. Oh my goodness, this is definitely going to be on GK, Praxis Core, middle school, high school, like all of the above, and my elementary people. Depending on how far yours goes, order of operations is critical. So let's go ahead and find a blank piece of paper that we can solve this on. Thank you guys for bearing with me while we solve these problems on paper. All right, 28 minus 10 divided by 2 minus 5 times 7 plus 3 squared. All I did was write the problem on my paper. What do I know about this problem? I know I'm simplifying it to get an answer. And I know without a shadow of a doubt that I am going to have to use order of operations. So that said, what is the order of operations? Order of operations is PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Now, here's what I want you to understand. Parentheses and exponents are partners. Multiplication and division are partners. Addition and subtraction are partners. So once I complete parentheses and exponents, multiplication does not have to come before division. At that point, we move from left to right because that's the direction that we read. At that point, you would just move from left to right and do whichever one came first. So I see an exponent and I see parentheses, and inside my parentheses, I see subtraction and division. So I'm going to solve that exponent first, and I'm going to keep everything else the same. So 28 minus 10 divided by 2 minus 5 times 7 plus 3 squared. What does squared mean? Do 3 2 times. 3 times 3. So that's going to be 9. I highly encourage you, even if you get a calculator, to not punch this into your calculator, because a 4-function calculator, which is this kind of calculator, does not understand order of operations. So it will not give you the right answer if you just punch that into your calculator. You have to solve it by hand a little bit. All right, so I have all of this plus 9. All I did was solve 3 squared. Now I'm going to go over here to my parentheses. What am I going to do first within my parentheses? Within my parentheses, I'm going to divide first. So I'm going to do negative 10. Yes, I know some of you are thinking that's a subtraction symbol, but it's attached to the 10. So I'm going to do negative 10 divided by 2. I'm going to do negative 10 divided by 2, and I'm going to get negative 5. So 28 minus 5, keep everything else the same. Because I did this negative 10 divided by 2. Now I'm going to finish solving those parentheses. 28 minus 5 is 23. Keep everything else the same. What am I going to do now? What am I going to do now? I'm going to do the multiplication piece of this. You're absolutely right. I'm going to do the multiplication piece of this. So I'm going to do the negative 5 times 7. Again, I know you're thinking that's a subtraction sign, but it's a negative 5. So negative 5 times 7 is negative 35. So I'm going to do 23 negative 35, which is just going to be a minus 35, plus 9. Now I'm within that addition and subtraction partnership. What am I going to do now? I'm not going to do the addition first. In fact, I'm going to move from left to right and just solve it, because now I'm within this partnership where I just do left to right. So I'm going to do 23 minus 35. Now I might pull out my calculator if I have one, just so I don't make a silly computational error at this point. 23 minus 35 is negative 12 plus 9. And negative 12 plus 9 is going to give me a negative 3, which is B. Anybody have any questions about the process that I just did to solve that, or to simplify that, should I say? We didn't solve anything. We simplified that problem. All right. Looks like we have time for about one more problem, and then I'm going to throw it back to Dr. A, and he has a special surprise code for all of you for tonight. All right. What information can you deduce from the following equations? 2x plus 3y equals 24, and 2x equals 3y plus 12. All right, there's not a whole lot I can deduce from this right now. What I'm going to do is I'm going to put them into y equals mx plus b form, because if I get it into, and let me find that paper that we were working with earlier, if I get it into y equals mx plus b form, then I can see what kind of slopes they have, if they have the same y-intercept or not. So I'm going to go ahead and write these problems down and get them into y equals mx plus b form. So 2x plus 3y equals 24. I'm going to subtract the 2x from both sides. So I'm going to do minus 2x, that cancels out. 3y equals negative 2x plus 24. Because remember, from earlier, we can't combine those items, but we can subtract. Now I'm going to divide both sides by 3. I'm going to divide everything by 3. And I get y equals negative 2 divided by 3x plus 8. Because I know that this is slope-intercept form, I'm not going to simplify this into a decimal. I'm not going to write 0.6666666 repeating, because all this is a rise over a run. So I'm actually going to leave it like that. Now I'm going to do that same process for the second equation. So 2x equals 3y plus 12. I'm going to subtract 12 from both sides. So I get 2x minus 12 equals 3y. Because remember, I'm trying to get y by itself so that I have y equals mx plus b. Now I'm going to divide both sides by 3. And I'm going to divide everything by 3. So I get y equals 2 over 3x minus 4. So these are my two equations now, and I'm going to circle them amongst all of this work so we can see it. Now, what do I know about parallel lines and perpendicular lines? What do I know about parallel lines and perpendicular lines? I know parallel lines are going to have the same slope because they're riding together. They're going up and down at the same pace, if you will. So these are not parallel. They look the same, but one is positive and one is negative. So they're not parallel. Perpendicular lines are going to have negative reciprocal slopes. So if this was 2/3, this would have to be negative 3 over 2. If this was negative 2/3, this would have to be positive 3 over 2. But because they're not flipped and they're just negated, they're not perpendicular either. So they're just non-perpendicular lines. Do I need to figure out what their intersection point is? No, I don't, because the only answer choice on here with non-perpendicular intersecting lines is letter C. So I'm just going to pick letter C as my option. All right. Thank you guys so much for bearing with me tonight as we did math on cardstock and Sharpies, because my poor iPad did not work tonight. I I appreciate you guys hanging out with me tonight. I will see you next Wednesday for another Wednesday night math live session. We will continue working with these problems. And like I said, as always, if there's any problems that you want me to solve on a Wednesday night math session, drop them in the chat or comment in our customer hub, and I'll be happy to add them to our stream on Wednesdays. With that said, I'm going to turn it back over to Dr. A. So, Dr. A, are you with us?
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.